Hello, and welcome back to Lecture 4 for CS 128 Honors. Today we will be covering enums and matching. So, for today, first we will be reviewing matching, then we will cover enums. We will then cover matching with enums, which is the easiest way to analyze them. Then we will be covering again the special enums that we covered in Lecture 3, result and option. So, a match expression lets you compare a value against a series of patterns, as shown here on the right. The patterns may be integers. Like, for example, when course is an I32, we can compare it against other I32s shown here. And then we can return a different value from the match block based on the pattern we find here. This match block, since it's 128, will return Professor Nowak, which will then be assigned to the professor variable. A pattern must be exhaustive, which means that you must cover every single possible pattern in the set for an enum specifically. Like for this, we could cover anything, or if we haven't covered every single possible integer, we must allocate some sort of wildcard. Like, yeah, here, I don't know the professors if the course isn't one of these courses. This underline, it refers to a wildcard, so any pattern is accepted by this. So why would we use enums? Well, enums are useful for categorical values, such as day of the week. Like, for example, you can define an enum based on Monday, Tuesday, Wednesday, and so on. And you can represent it also to limit your scale of quantized values. Like, for example, if you want integers 1 to 7, you can define an enum for individual ones. We'll talk about defining enums on the next slide. So, we can define an enum by using the enum keyword, as shown right here. Then we put the name of the enum, and then in brackets, you put all the variations. For example, this day of the week has 7 variations, one for each day of the week. Then we can define a variable of the type of that enum as such. It is of type day of week, and we do day of week, double colon, and then the day of the week we want to choose. This is also called a sum type, since you can only have the number of elements. The only variations is the sum of the number you have here. Each value here is called a variant. So Monday, Tuesday, Wednesday, they're all variants of day of the week. And these variants can contain subvalues, as shown in the enum groups here. A single variant comes with a single string. A pair comes with 2, trio comes with 3, and you can even put collections like vectors in here. To match on enums, you can use the match keyword and then just define it as such, just like you would have defined it earlier. And in addition to that, you can use union, like the or symbol, to combine two cases in a match statement. Like if it's Saturday or if it's Sunday, it'll print yay weekend. And just a reminder, you must cover all possible patterns. Like here we cover Monday, here we cover Saturday and Sunday, and then the underscore. The underline represents every single other possible value. So, this is an example of defining variance. We can do as such here. We can keep an integer counter of the number of classes we have each day. Like here, we can define Thursday as day of week Thursday with the value 3. And we just don't have any date or numbers here since we don't have classes on weekends. Then we can use this to match based on the number of classes. We can use the the values of the variance in the match statements. Or you can define a variable in the match statement to be used later. Like for example here, Monday, you have a number of classes. And here, in the match statement's return value, you can use that variable that you wrote right here. Or you can match based on the number of classes, like here. If the Tuesday that you've matched with has a value of 3, it will print this line. If it has 4, it will print this line, and this wildcard again will cover every other possible case. So the option enum is like this is the option enum we covered last lecture. So consider a pointer from C++. It can either point to somewhere on your computer, or it can point to 0, a null pointer, which essentially is used as a value that tells you that this is nothing. Nothing goes here. And you must check every time whenever you use that pointer to make sure it is null, or to make sure it is not null, because if you dereference the null pointer, you'll crash. This is the job of the option enum in Rust. It offers you a different way of handling none values, like this. It won't make you check every time, but you can, it will make you check every time, but you'll be guaranteed with 100% certainty that you either have the value that you want or it is no value, and you must handle this every time. Don't worry though, this is easy. So just like here, this is one way to define option using an enum. You can call sum, like we defined earlier. Sum has of type t, and this type t here is a reference to a raw string, like as such. This works just as before. So the result enum is like an exception from C++. When a function fails, it can return an exception, which will crash the program. But in Rust, we don't exactly want it to crash yet, so we treat errors like values, and these values are stored in the result enum. So either is a successful run, and it'll have the return value, or you'll have an error, and then you'll crash. But instead of crashing, you can handle that error with your own code, instead of doing a try catch statement or try except. So the result enum is as shown below. It either has OK, which means it ran successfully and something returned, or it has an error with a different type, because Rust has many default error types, or you can define your own. If you don't want any meaningful value for either of these, you can use the unit type here as a placeholder for nothing. In the standard library, you mostly encounter these result enums when handling I/O operations, such as file readings, where, for example, the error could be file not found, and it would return a file not found error in this bracket. So, some useful methods. Options and results come with is sum or is okay for their successful checks. This returns a Boolean value with whether, like for example, the result is an okay value, then you can unwrap it safely. And is none and is error checks the opposite. An unwrap or, instead of panicking like the normal unwrap, would return the value stored in the option or enum, like here. It would unwrap this value t, or it would return some default value if it's, for example, a none that doesn't contain any value. But even better, we can match. You can match, for example, here, as we discussed in last lecture, this get returns an option, which either can be something based on the thing stored in that location of the vector, or it can be none if the index is invalid, just like so. And then you can do match return value as well for a result. For this example, we define the return value as a string, and the error value is a string, so it's easier to print. So here, we return, if it's okay, this return value, and then we can use it in this block of code. Or the error value, we can use it in the block defined there. ePrint is just printing to the error buffer instead of standard out. So you could use these, for example. You can use expect, which gives you the successful value of okay, but it will panic and shut off your program no matter what if it fails. And unwrap, which also crashes your program if it fails. So these are usable but highly unadvisable. Well, thank you for listening. That was lecture 4.